Hello everyone. In this video, I'm going to be going over some of the basic reactions that are going to be on test 1. This will be the easiest exam out of all 3 exams, and just like in Orgo 1, it is the most important exam to do the best on because it can really set you up for a really good grade at the end of the semester. And unlike in Orgo 1, Orgo 2 is much more dependent on the grade that you'll get is much more dependent on how well you do on the final, and the final in Orgo 2 is very different than the final in Orgo 1, and I'll be talking about that in other videos more. But really, for Orgo 2, the exam 1 is essentially a brief review of the Orgo 1 reactions that you've learned, and you're going to be required to remember some of the more important ones, and there are a few new ones that you will have to know as well, but it's really not that much. And in terms of the reaction sheet is a total of 21 pages. There's a bit more reactions than that because the reaction sheet kind of gets a little bit not as good towards the end in covering the material properly, but it's 21 pages in total, and those will be all the reactions that you have to know throughout the semester. And just to put it in perspective, exam 1 is only going to cover over the first 2 pages. So really, you're basically doing 10 pages for the other 2 tests that are coming up each. So it's really not that bad for test 1, and if you just kind of focus and just break the learning curve at the beginning and get back into the shape of doing reactions, you should do amazingly on the first exam. So let's just get started then. So the first page is some new stuff, but a lot of it is stuff that you should have seen before. The only ones that are really new is this one right here. This one is kind of irrelevant. I've never seen this really used before. There's a lot of random reactions in the first 2 pages. As you go on, the reactions are more relevant, less things that less things that you will not see. And so, first, the main important reaction for this exam is this one right here. So, cleavage of ethers by strong acids. And I can share this reaction sheet. I'll try to share it somehow, but everyone should essentially have it, whoever's in the class. So let's just go over the mechanism for this reaction. So essentially, we're going to have an ether. Okay, and an ether is anything where you have an R group, so it's any R, O, R. Okay, that's an ether, and essentially we're learning how to cleave the bonds with the oxygen to the carbons using a strong acid. And so, as you can imagine, as this is implied through the name, so we can use HI, HCl, or HBr. These are all acceptable to use. And essentially what happens is the oxygen is going to take one of these hydrogens, okay, and then we will get this. And so essentially what's happening at this point is I have now activated these carbons essentially. So this oxygen is now positively charged, and it's going to want to have more electron density, so it's going to start pulling through the signal bonds that's connected to these carbons, and essentially it's going to create a dipole moment. Okay? And these carbons now are going to become partially positive. And essentially they're going to become electrophilic sites. And now that they're electrophilic sites, when I do this reaction, obviously I create this. Now I have an I minus, right? And so this I minus, which now becomes the nucleophile, is going to come and it's going to attack at either one of these electrophilic sites. And then it's going to give that pair of electrons to the oxygen, which is what it wants anyways, right? So the oxygen's pulling on those bonds, and now the bond is going to break, and it's going to get those electrons. It's gonna be happy again, right? The oxygen wants two pairs of lone pairs, and it wants two bonds, and that's what oxygen requires to be neutral. And so after this first step of this reaction, right? I should probably draw this cleaner. Okay. So the I minus is going to come. It doesn't matter which one. And it's going to give it to the oxygen. And so now what I have is I have this. Right? So I have this on this side has been created. Plus on this side, I have that. So now I have this and I have this. And then essentially what happens, there's still more strong acid left in concentration in the solution. And so the alcohol that I just made is going to keep going, right? And essentially the same thing repeats. So I'm going to get right? So I'm going to get that, and the same thing happens again where this is a good leaving group essentially, right? It's going to pull on the sigma bond, it's going to make this carbon a electrophilic site, and I'm going to have my I minus come again and attack, and this gets kicked off. And essentially what we make is we make two of these, right? In this case, it's symmetric molecules, so I'll get two of these, but it could be something else if it's not symmetric. And that's essentially what this reaction is. It's just the cleavage of ethers into these substituted halides. And if we look at the reaction sheet, that's essentially what we're doing, right? So I'll get a bromine right here, and I'll get a bromine right here. So wherever the oxygen, the two bonds that the oxygen had, will be replaced with a bromine respectively, right, to each one. And the oxygen will become H2O. The only exception, as you might know, is that no SN2 or no nucleophilic attack really on sp2. So whenever you have one of these bonds that's to a either what we call aryl or vinyl, right? You do not cleave that bond because this bond cannot be attacked. So that's the only exception that you have to be aware of. But aside from that, it's a pretty simple reaction. This is a reaction that you've seen before, the top one. This reaction I wouldn't worry about too much, just simply a memorization, but I've never memorized it personally, and I've never seen it come up. Up to you, really, if you want to spend time on that. Here we have MCBA. Really, all this reaction sheet is just pointing out some of the important reactions that could show up, and that will definitely be used. So you'll definitely see MCBA on the exam, just the formation of the epoxide. And then we have intermolecular Williamson, where you have a strong base, and then you have a alcohol and a leaving group on the same molecule. And essentially what happens is nothing really too crazy. The strong base is going to deprotonate the acid, right? And this is going to turn this into an O minus, right? And this O minus is going to attack itself. So we have a strong base that's formed on the molecule, right? And then I have a leaving group, right? A primary alkyl halide. That's what we require. And what's going to happen is basically the E2SN2 exception. So if you have a strong base and a primary alkyl halide, this strong base will attack like SN2. And so essentially the O minus is going to come and attack the bromine. And that's how you get these rings. And so nothing too crazy. And then we have opening of epoxides, both in the acidic condition and the basic condition. I've already made a video about this in the past. It's fairly simple. You just need to know that when we're doing things in the acidic condition, right, that I will open the ring from the more substituted side, right? I'm going to protonate first, then, the H2O is going to come and attack, or it could be something else, is going to attack from the most substituted side. In the basic condition, we're attacking right away without activating the epoxide. The epoxide must be activated in the acidic condition. We do that by protonating the H. That's why it's acidic. And that makes it more electrophilic to attack these carbons. In the nucleophilic condition, we're just immediately attacking, and we're attacking this unstable ring structure that is the epoxide. And the oxygen is always pulling on these bonds because it's electronegative. And so this is going to attack from the least substituted side because it's the most energetically favorable and quickest way for it to attack. And we're not going to look at, degree of partially positive carbon and so on and so forth. So this will attack from the least substituted, this will attack from the most substituted, and that's how the epoxide will open. Okay, and that's what you need to know. Now, there's only two more reactions essentially that you have to know. There's two new reactions. There's one called the conjugated system. When we have conjugated systems and we're introducing things that are electrophilic, or whenever we're doing MBS, either or, there'll be two conditions that we're looking at. We're looking at either the kinetic condition, where it's low temperature, and we're looking at the thermodynamic condition, where it's higher temperature. And I'll do separate videos on these two, so that, because these are probably going to be the ones that people struggle with more, so that you can just come back and look at them on your own. Okay, so that'll be all that I need to tell you guys for this video. So next video will have this reaction and the Diels-Alder reaction, which is probably the hardest reaction for exam 1, and people usually end up screwing that up most of the time. All right, thank you, and see you in the next video.